two, we all do have how do the different conceptions of PCK shape the methods devised for assessing PCK. So I think that fits perfectly to our model discussion in the morning. So I will firstly say something about the question and about some things about the model and the methods, and then I will go in detail for our model and why we think it is like it is today. Yeah, starting point. A minute ago it worked, so maybe I can try the other one. So we do have the question. The conceptions shape the methods we use. For me, it's, I see it in the first moment, there has to be another way around. So if I know what I want to test, for example, a large-scale test, I do have to think about the model in a different way than I think, oh, I want a model that covers everything I could think about PCK, and I don't want to test anything. So I will start with some assumptions about the conception. Firstly, we do have, often unverbalized assumptions, and these are some assumptions we do have, and I think we share a lot of them. So we have the point that we think you can measure professional knowledge and in special PCK. Then we think that you can say, oh, we do have these facets of PCK, like knowledge about student learners, knowledge about their problems with learning. And then we say, if we use this mostly normative set facets, we can form one PCK out of this. We have the point that we say, if we measure some of these facets, and for sure we can't measure always every facet we could think of, then we can still call it PCK. So this is what we do. We measure knowledge about concepts and experiments and students' preconceptions, and always we say we measure PCK. And then there's the one the conception of PCK and the conception of professional knowledge is our model of professional knowledge. So this is the one side. The other side is the assessment. I said it before. We are interested in a large-scale study. We want to find a correlation between teacher's knowledge, his doing, and the student's achievement. We wanted to use a paper and pencil test, and later on there came that we would use open questions. So this again is coming back to our conceptions. We want to have a model that we can test. And last but not least, we do have some results in our study, and these results again shape our model. So I think we discussed it in the morning. It could happen that everyone said, students' outcome should be in relation to teachers' knowledge. If now everyone does testing of this and a lot of studies and no one sees this connection, maybe we do have to change our model in this way. So this is about what I think this is this question about. And now I will say something more about the model of professional knowledge we used and why I don't think that one model, what we would use at all, would be solve our problems. So it's an evolution. I will start with the point when I came to the program project. It was summer 2010, and there have been some discussions before, and we had two levels of a model. The first level was, we do have three areas, CK, PCK, and PK, and they are distinct, but they should have a connection. This is the easy level. The second level is going more into detail and was really used for test construction. So you see a lot of dimensions. The first thing is we wanted to cover some knowledge areas. Knowledge about facts, knowledge about doing, knowledge about reasoning. This is for one. Then we wanted to use some different topics. So for physics, it was mechanics in the heart, but we have used a similar model for the biologists and chemists, so they had for sure different themes. And then as a third X, we do have, facets, I said it before, experiments, concepts, conceptions, and some things who are more general, like classroom management. Now you see this, and it's getting colorful. We do have the three areas, CK, PCK, and PK. So for our PCK, we wanted to use all three axes. So this looks like you have places in the model, so maybe you have to develop 10 items or knowledge about students' preconceptions in mechanics on the area of conditional knowledge. This was at this beginning, but we knew at this time we would have only, I think, 1 hour test time for the PCK test, so it couldn't work like this. But I will explain it further. We do have a second axis, content knowledge. And so what you see is we don't use the facets in the content knowledge, so we said at this point of time, this content knowledge is something every, in this case, physicist could know too. Maybe he would be a bit slower on it or so, but it should be possible for physicists to solve the CK parts. The third area is the PK part, and there again we wanted to cover the knowledge areas and some different facets like classroom management. But this is not connected to anything with content part in kind of physics or science. So you see the problem, there are a lot of there had to be really, really many items to test this model, and we couldn't do this. So because we are working with teachers, we can't say, oh, we will get 3,000 teachers and then it would work. Next step in the evolution was the following, a list. And so a color-coded list again. These are the same things I've seen before in the PCK part. We have some knowledge in the CK part and in the PK part. So the problem with this is you can publish it easily because it's only a list, but nothing is connected to each other. And so last year when I went to Julie, we worked on, I forgot one thing. But after this there will be the part I worked with Julian. So you've seen the bubbles before. In the beginning we thought there are 3 things, and we don't know how they are connected. Now we got the part there has to be a connection between CK, PCK and PK, and it's fuzzy. We don't know where our items are. And so I will show you in a short moment the model we are using now, but I could say we used until this week. So, so I will describe in a short words, especially in the difference to the models before. So what you do see here is there are different areas of knowledge, and they are not this fuzzy in between. They are, again, color-coded. But we do have these items, and we do have the easy part of CK items and PK items, but we do have our PCK items, and they can have a part of CK, I say a bigger part of CK, or a bigger part of PCK, but we know the C and the P are both in our PCK. So one of the questions is, can there be a pure PCK? Then you see this topics before, the mechanics and so. This is now in the middle of the model. We said that it wouldn't be possible to test our model, so we said, I think that's something we are coming here now. Maybe PCK is really some integrated knowledge, and not here's knowledge about students and here's knowledge about experiments. So we could put this together here, and all these 3 parts have an influence to our PCK, but maybe they can't be distincted. And the same in the end as for our knowledge areas. They are not distinctive, but it was really important for us to know we need items who are not only on facts, but things about more doing or reasoning. And we didn't want to forget anything. So what's important is that this model, I had this model after I had my test, but I think that this model fits the test much better than the model we had at the beginning. So now I will come to the last slide at the end. We do have now a real nice model. I'm fond of it, but we started in our program project with the model with the axis, and everyone did something else with this model. So this is, and in the end we are in the program project at a point where we can say we can't, sometimes we can't say this outcome in physics is the same than the outcome in chemistry. So I'm afraid that this is the problem we are facing here now. We found the model in the discussion earlier this morning, but I think everyone will describe it differently, use it differently, and so we do have to talk about the vocabulary we want to use and not only about a nice picture. But I have some hope. We do have one study using 2 different PCK tests, one about mechanics, one about electricity, with the same pre-service teachers, and they really correlated good with each other. So the one PCK test correlated higher with the other PCK test than they did with the CK tests, which were fitting to their own, to the PCK test. They were well also. So even if we don't have one model, we could develop different tests and different measurements, and maybe all of this is PCK, and we could talk about this. Thank you.